Notes 24, parallel and perpendicular slopes. Describe the slopes of the pair of the line segments in each example. They have been numbered to help you explain. So on slope number 1, you can really go from this point to that point to that point to that point. So that means going up to over 1. So the slope of number 1 is 2. And then the slope of number 2, basically you're doing the same thing. Up 2 over 1, up 2 over 1. So the slope of line number 2 is also 2. So parallel lines have the same slope, but they can have different y-intercepts. If they had the same y-intercept, then they would be the same line. So parallel lines have the same slope, but different y-intercepts. All right, example 2, slope number 3. So again, I'm going to go ahead and put a point there, go up 2 over 1. So the slope of number 3 is 2. And then on number 4, I'm going to go up there. So I'm going to go up to left 1. Well, when I go up 2 and left 1, that's 2 divided by negative 1, which is negative 2. So these are just, they're not perpendicular because they don't intersect at 90 degrees. They are just intersecting lines. So intersecting lines cross at any given point. All right, then let's look at example 3. So the slope of line 5, so I'm here. And again, you can keep going. Excuse me, you can keep going. But I'm just going to go from this point to that point. So I'm going to go down 2, right 1. Well, when I go down 2, it's a negative 2. And right 1 is a positive 1. So negative 2 divided by 1 is negative 2. The slope of number 6. So I have here and so forth. So I'm going to go up 1 over 2. So the slope of number 6 is 1/2. So perpendicular lines, this is going to be quite a bit here, so you need to write small, form 90-degree angles their slopes have opposite signs. So one's a positive, one's a negative, and are flipped. Okay, and another mathematical term from flipped would be reciprocated. I'm going to go ahead and put that in parentheses. Reciprocated. All right, so they have opposite signs and then they're flipped because the slope of number 5 is negative 2, which is like negative 2 over 1. So when you flip that and change the sign, you get 1 over 2. All right, down here at the bottom, it says draw a line from each point using the given slopes. Label the type of lines they represent to each other, such as parallel, perpendicular, or just intersecting. So on problem 1, line A, the slope is going to be 3. Now, here's the thing. If you start here at 3 and try to go up 3 over 1, you're going to go off the graph. So we're going to start here at this point, and we're going to go up 1, 2, 3 over 1. And we'll do that one more time. 1, 2, 3 over 1. And we'll draw our line here. So this is line A. And then line B, the slope is down 1, right 3. So we're going to go down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Okay, so this one is line B. All right, so you can see that they do form 90-degree angles. They are opposite signs, so a positive 3 and a negative 1/3. And if this is 3 over 1, when you flip that, that becomes 1 over 3. So these are perpendicular. All right, let's take a look at problem 2. So line C is 2/3. And then line D is 3/2. So since line C's numerator is smaller, we're going to use this point here. So we're going to go up 2 over 1, 2, 3. Okay, so I went up 2 and right 1, 2, 3. And then, so that's all I can do actually there. Because even if I try to go down to left 3, I would still go off the graph. So this is line C right there. All right, then line D. So we start here, we're going to go up 1, 2, 3, right 2. And we could go down 1, 2, 3, left 2. So we could actually put a point way down here. Okay, so this is our line D right there. And there's nothing special about this. They're not parallel. They don't intersect at 90-degree angle. So these are just intersecting lines. All right, let's take a look at problem 3. Line E is -1. So that's going to be -1 over 1. So since we're going to be going down, let's go ahead and start with the upper point here. So we're going to go down 1, right 1. And you can keep doing that, down 1, right 1. I like to get at least 3 points. It helps my line be a little bit more accurate. So this is line E. And then line F is 1, so that's 1 over 1. So from here, from this point right here, I'm going to go up 1, right 1, up 1, right 1. All right. So they look perpendicular. They look like they intersect at 90 degrees. So on line E, you have -1 over 1. If we change the sign, it becomes positive. And if we flip 1 over 1, it's still 1 over 1. So these are perpendicular. All right, let's look at problem 4. Line G is 1 over -4. So we'll just up 1. Let's see, we're going to have to go left 4. So let's start with this point right here. So we're going to go up 1, left 1, 2, 3, 4. And that's about all we can do on that. We can't get a third point because we'll be off the graph. All right, so that's line G. And then line H, we're going to go down 1, right 1, 2, 3, 4. And that's all we're going to get there. All right, and you can see that they do look parallel. And if you look, the only thing different is that line G has the negative in the denominator, and line H has the negative in the numerator. It doesn't matter where your negative goes in a fraction. You just can't have a negative in both the numerator and denominator, because a negative over a negative would be a positive. So these are parallel. All right, let's go on to the back page. And it says, for the following equations, write what the new slope would be for a designated line represented in bold. So on problem 5, if you want a line or a slope that's parallel to that slope right there, then your slope needs to be 3. They need to be the same slope in order for the lines to be parallel. Problem 6 over here, we want it perpendicular. So remember, that's negative 2 over 1. So perpendicular is opposite signs. So instead of a negative, we're going to be a positive, and then we're going to flip that. So 2 over 1 would become 1 over 2. Problem 7, we want this to be perpendicular. So you have 1/5. So we're going to flip that. So 1 over 5 would be 5 over 1, and 5 divided by 1 is 5. And since this is a positive to begin with, then we want it to be a negative. Remember, perpendicular is opposite sign and it's flipped. Number 8 is parallel, so the slope here is a 1. They just have to be the same. Number 9 has to be perpendicular, so this is negative 6 over 1. So we're going to flip that and make it positive. Number 10, parallel, is going to have the same slope, so it'll be 3/4. All right, let's take a look at 11, 12, and 13. It says, graph the following equations on the graph below. Label your lines with the equation. You may either graph using the slope-intercept form or a table of values. Identify whether they are intersecting, parallel, or perpendicular. To create a second line, you can press Tab. To type an equation with x equals, press delete 6, then type the equation. So those are instructions that you can use in your calculator in order to see the lines graphed. Especially, we haven't worked with any that have an x equals, like on problem 11. All right, so we're going to go y equals negative 3. That means it needs to go through the y-axis at negative 3. So this is y equals negative 3. Then we have x equals 4. It's a vertical line. It's going to go through the x-axis at 4. So this is x equals 4. And these are perpendicular because they do form 90 degrees. Now, their slopes, one has an undefined slope and one has a 0 slope. So that really doesn't match up with, how before on lines, if they were perpendicular, they were opposite reciprocal. So we can't really match that with this, but they are, regardless, they are perpendicular lines because they form a 90-degree angle. All right, problem 12. I want to start with the first one, the y equals negative 2x minus 1. Go negative 1, and then I'm going to go down 2, right 1. Sorry, that needs to be erased. And then we're going to go down to right 1, or you can go up to left 1 and just keep putting a bunch of points. So that's that line there. So this is y equals negative 2x minus 1. And then the other one, we're going to start up here at 5. 1, 2, 3, 4, 5. And then we're going to go down to right 1, down to right 1, or we can go up to left 1. It does not matter. And I'll go ahead and draw that. And we see that they are parallel. And the reason why they're parallel is because their slopes are the same. So these are parallel. All right, and the last one, we're going to start this one right here at negative 6. So 2, 4. Negative, wait, 1, 2, 3, 4, 5, 6. Yeah, that's right. So negative 6, and then we're going to go up 3 over 1 because that's a slope. So we're going to go up 1, 2, 3, and over 1. Up 1, 2, 3, over 1. We could keep going if we wanted to. 1, 2, 3, over 1. So this is my line right there. And this is y is equal to 3x minus 6. And then I have where we start at 4. And we're going to go down 1, right 3, down 1, right 3. Or we can go up 1, left 3. It does not matter. And then here is that line there. So this is y equals negative 1/3 x plus 4. And it does look like they cross at 90-degree angles, but we can take a look at the slope. Are they opposite signs? Yes. Are they flipped? Yes, because this 3 right here would be like 3 over 1. So when we flip that, it becomes 1 over 3. So these lines are perpendicular. All right, and the last thing we have down here, it says is a review. So find the x-intercepts, then graph both equations on the same grid. So the x-intercept is when we let y be equal to 0. So when we do that, we're going to have basically 2x plus 6 is equal to 0. So we're going to subtract 6 from both sides. So we have 2x equals negative 6. We divide by 2. So x is negative 3. So our x-intercept is negative 3. Then our y-intercept, that's a little bit easier because it's when our x is 0. So basically right here, when we put 2 times 0 for our x, that's 0. So basically we can just cancel out the whole 2x term because 2 times 0 is 0. Then 0 plus 6 is 6. All right, so let's go graph this. So we have our x-intercept at negative 1, 2, 3, 0, and our y-intercept at 0, 6. 1, 2, 3, 4, 5, 6. So that's our line right there. So this is to problem 14. I'm just going to put 14. All right, then on 15, the x-intercept is when y is 0. So basically right here, 4 times y, 4 times 0 is 0. So basically it's just canceling out that whole 4y term like we did up on 14. So x equals 8. All right, then the y-intercept is when x is 0. So basically it's just canceling out that x right there. And then we can divide both sides by 4. So 8 divided by 4 is 2. So when we go graph this one, this is actually going to go off the grid here. Because we have, wait, something wasn't right. Let's go back. I don't know if this one was right. Let me erase a few things. Sorry about that. Okay, we're going to try this again. So the x-intercept is when, oh, I forgot. There's a typo. This is supposed to be a 2 right here. That's why it wasn't working out good. Sorry about that. We're going to take that away. All right, we're going to start over again here. So our x-intercept is when y is 0. So basically it's canceling out that y term. We're going to divide by 2. And 8 divided by 2 is 4. So then we're going to come over here and we have 4, 0 there. All right. I'm going to erase all this. I'm going to put that 2 back there. Oops. Put the 2. Oh, come on now. Put the 2 back there. Okay, so now when x is 0, so basically we cancel out that x term. We divide both sides by 4. And this one was okay. It was just the x-intercept that was messed up. All right, so we're going to have a 4, 0 and a 0, 2. And there we go. So this was problem 15 right there. All right. Those are some pretty long notes, but they're good information on perpendicular and parallel lines.